By this lecture, we shall start our discussion on Fourier series. But before going into the Fourier series proper, I want to cover up for a few mathematical preliminaries which will be of main importance in Fourier series. So we shall consider a few mathematical. We shall consider the first of mathematical preliminaries. The main thing, the central idea behind the Fourier series is the completeness and orthogonality of the sine and cosine functions over the interval of period 2 pi. By completeness, we mean that if we have an even function in the defined in the interval 0 to 2 pi, then it can be represented as a combination of cosine functions which consist of its fundamentals and the overtones. And similarly, an odd function can be represented by the sine functions only. And in general, a function which is neither even nor odd can be represented as a combination of sines and cosines. These are the meaning of completeness. So, and what do we mean by orthogonality? We shall discuss here mainly the concept of orthogonality. Now, before going to that, we consider an interval of between a to b, so that this interval is delta, and we shall study the properties of sine and cosine function when integrated over this interval. So, to start with, we first consider this. The notation is that it is the integration of sine function for integer n. The definition is a to b sine of 2n pi x upon delta dx, where delta is equal to b minus a. If we integrate it, it is a straightforward integration. Pi, and then we will have cos functions. This is of the form cos c minus cos d. So this is going to be delta upon 2n pi times 2 sine of Now note that b by a is delta, so the last term becomes n pi, sine of n pi. So this becomes and for integral values of n, this is equal to 0 for n belongs to integer. So the result is 0. So we rewrite it as this is 0, one result. Then we consider the similar expression for involving cos function. So the notation is INC. This is this n is this n, and sine for s, and for cos is this cos of If we integrate, we will find delta upon 2n pi, then sine of 2n pi b by delta minus sine of 2n pi a upon delta. This is sine c minus sine d form, so this is equal to delta upon n pi. 2 comes over from here, and which adjusts the 2 in the denominator. This is cos part is the n pi b plus a by delta, and sine of n pi b minus a by delta. Now, for integral values of n not equal to 0, this form is 0. So this is 0 for n not equal to 0. What happens to n is equal to 0? For n is equal to 0, we write it as, for n is equal to 0, we write I0c is equal to this expression with n tending to 0. And you know that this part simplifies to simply n pi. This is simply n pi. So we will have delta coming from this, and we write limit n tends to 0 cos of n pi b plus a by delta times sine of n pi divided by n pi. This n pi is taken in the denominator. So the limit of product of two functions is the product of their limits. So as n tends to 0, this tends to 1. I have missed delta here. Delta has been missed. This delta will be there. So this is 1 into, since cos 0 is 0, and this 1 is b, because this is sine of n pi by n pi with limit n pi tends to 0, which is equal to 1. So the result is 1. So if we combine these two, we write INC is equal to limit a to b cos of 2n pi x by delta dx is equal to delta times Kronecker delta and 0. So when n is not equal to 0, the result is 0, and when n happens to be 0, the result is simply delta. This can also be obtained very easily. If we put n is equal to 0, the integrand becomes 1, and when you integrate it between limit a to b, it is delta. Now we come to the similar expression involving product of two terms. It may be two sines with different n values. One is n, other one is m. Two sines or two cosines, or a sine and a cosine. So we define it like this: INMSS. That means integration from a to b sine 2n pi x upon delta sine of 2n pi x upon delta dx. N and m both are integers, are positive, non-negative integers. So first thing is that we convert it into we have converted the product of two sine functions into cosine functions as the sum of cosine functions. Now if we integrate these two separately, we will have, first the common term will be delta by 2 pi will come out. So this is delta upon 2 pi will come out, so that it makes delta by 4 pi. Already 2 were there, so this is delta by 2 pi. If we integrate this quantity, we will get 1 by n minus m times sine of 2n minus m pi b, the upper limit of minus delta sine of 2n minus m pi a, lower limit by delta minus this part, integration of this part. Let me explain this term once more. When we integrate this, we will have sine function and an argument will come out. This is delta by 2 pi. Delta by 2 pi has been taken care of, and 1 by n minus m is taken care of, and then the sine function with upper limits and lower limits. Similarly for the second term. If this is again in the form sine c minus sine d, so a 2 factor will come from this, and this 2 factor adjusts the 4 in the denominator, so it becomes delta by 2 pi. This is 1 upon n minus m, and then this is cos of n minus m pi b plus a by delta. I am using the formula of sine c minus sine d. You see that this term is simply, this part is simply, because b minus a is delta, it is n sine of n minus m pi. Similarly, this part is n plus m pi. So we write it as this term. when n and m are integers, as we are considering all along, and they are not equal, these terms are 0, so the result is a 0 when n and m are integers but not equal to 0. This is 0 for n not equal to m. A special care has to be taken for n is equal to m but not equal to 0. When n and m are equal but not equal to 0, this term do contribute, but this term there is no contribution from this term. So we write this as I n s s is equal to limit n tends to m, that is n is equal to m. We will have this part delta by 2 and this pi will be going there, so we have delta times cos of n minus m pi b plus a by delta, this is cos, times sine of n minus m pi by n minus m pi. As n tends to m, this part is sine x by x tending to 0, so and this part is 1, so the result is simply delta. So we rewrite this as that it is equal to 0 when n is not equal to m, and the result is, sorry, I have adjusted everything, but these two were missing, so this is delta by 2. These two were missing. So when n is equal to m, the result is non-zero, and otherwise it is 0. So we write both the options together as delta n m. This is known as the orthogonality of sine function over the period 2 pi. Here we have performed a general calculation in the sense that we have converted a limit, any limit a to b into 2 pi. If we write the limit to be a is equal to 0 and b is equal to 2 pi, then this relation reads as, this delta is equal to 2 pi, so relation reads as sine of nx sine of mx dx 0 to 2 pi, and it is related to a delta function nm. This is called the orthogonality. So we write this as the orthogonality of sine functions. Sine functions, and the period is 2 pi. Here we have adjusted the period so that the effective period becomes 2 pi. Now we come to the conclusion or consideration of the case of cos function. So next we shall consider the product of two cosine functions. So our next see, I hope now the notation is clear. This is integration from a to b cos of 2n pi x upon delta cos of 2m pi x upon delta dx, and this can be written as half of a to b cos of n plus m pi x upon delta plus cos of 2 this upon integration, as we did in the case of sines, becomes 4 pi for the second term. Sine of 2n minus m pi b by delta minus sine of 2n minus m pi a by delta. This is sin c minus sin d form, so 2 factor will come and this will be delta upon 2 pi 1 minus n plus m, and this term becomes cos of n plus m pi b plus a upon delta, and then the second term will be sine, and I am skipping the step. This is n plus m pi. For the second term we will have 1 upon n minus m, and similarly this is cos of n minus m pi b plus a upon delta times sine of n minus m pi, and so this is exactly similar calculation that we did with in the case of 2 sine functions. Here we have only 2 cos functions. You see that when n is not equal to m, n are not equal to m, this is a 0, this is 0. So the result is 0, 0 for n not equal to m. For n is equal to m, for n is equal to m but not equal to 0, that is, in that case this term doesn't contribute anything. So we are considering this part for n equal to m but not equal to 0. In that case this part doesn't contribute, this part contributes, and this is this part is on the limit n tends to m, this is 1, and when we couple this with pi, this is 1, so the result is delta by 2. So the result is delta by 2. And another thing is that when both n and m are equal and equal to 0, then this term also contributes, and the result is delta for n is equal to m is equal to 0. When n and m are equal, this is cos square, something cos square. So we can write this is like this: I n n c c is equal to, we can have this result more easily, which I am showing a to b cos square 2n pi x by delta dx. This is simply half 1 minus 1 plus cos of 4n pi x delta dx from a to b. When we integrate, this part contributes nothing at the result, and this part contributes, this is delta by 2. And for this, if we write I 0 0 cc, the result is dx from a to b, and this is delta, which is this one. Similar consideration may also appear for sine functions too, which we missed. So there is a restriction n m not equal to 0, and if n m is equal to 0, the result is multiplied by 2. So we summarize this result also over here. No, sorry, for sine function, this will 0 0 will not contribute. And m and is equal to delta for n is equal to m is equal to 0. So this is the orthogonality of cosine functions, and the last thing that is left is the product of sine cos functions, which is the last thing that I am going to consider. So our last candidate is I n m s c, or it may be cs. So this is a to b sine of 2n pi x by delta cos of 2m pi x by delta dx. So this is half now if we integrate as before, we will have delta upon 4 pi and from this part we will have 1 upon n plus m. When we integrate sine, we will have cos function, so we will have cos of this is cos c minus cos d form, so a 2 will come. So both the terms are sine terms. Because that second term will involve b minus a, which is delta, which cancels with this delta. This is the final expression. So now if we have n not equal to m, this is 0, this is 0, so the result goes to 0, so the result is 0. When n minus n is equal to m is equal to m, this term doesn't contribute, but there is a possibility of having contribution from this term. So when this is taken with this gives you 1, but this gives you 0. So there is, let me explain once again. This term can be written as sine of n minus m pi b plus a by delta, and this term can be written as sine of n minus m pi by n minus m pi, where pi is borrowed from this. So when the limit n tends to m, this tends to 1 in the limit n tends to m, but this tends to 0 because it is a sine function as n tends to m. So the result is 0 for n is equal to m as well as for n not equal to m. So the last thing as this is the 0. So this is the orthogonality property of the sine functions. We see that sine function having the same argument has non-zero value when integrated. Two sine functions of same arguments when integrated over the complete period gives non-zero value, and two sine functions of different arguments gives 0. Similar thing is for cosine function. And on the other hand, if we have one sine, another cosine function, and their product is integrated, the result is 0 irrespective of the fact whether the arguments are equal or not. So this completes our definition or our discussion on the on property orthogonality of cosine functions and cosine functions. Of sine cosine functions. In the next class we shall start Fourier series